Imagine you could take like the exact intellectual metabolism of your brain,
Right.
your precise tolerance for nuance, your threshold for nonsense, your specific appetite for complex debate. And imagine you could just turn that into a downloadable file.
It's a wild thought.
It really is. And today, we are looking at the actual engineering blueprints that make that concept possible. So for you listening, your mission in this deep dive is to see what happens when grand philosophical ideas about controlling your own digital attention are, forced into actual structured system design.
Yeah, the literal nuts and bolts.
Exactly. We are working from a companion technical document. It's by Lev Moten from N5 Digital, and it's titled Interface, Training, and Operational Design. So, okay, let's unpack this because we're officially moving from the why of previous papers to the how.
Right, which is always the hardest part.
Totally. We're leaving the philosophical essays behind and entering the incredibly unforgiving landscape of system architecture.
And, that intermediate step between philosophy and code, that is where most ambitious internet reforms just fall apart.
Yeah.
What we are analyzing here, it isn't a final product demo, and it's not raw lines of code either. It is the architectural bridge. The document stresses that a filter entirely owned by the user must be cognitively serious and operationally disciplined.
Meaning it can't just be vibes.
Exactly. It cannot just be a theoretical wish list. It has to define mathematically and structurally how data flows from a noisy platform right through a filter and then into your consciousness.
And you can actually see it taking operational shape in the source material, which is so cool.
Yeah, the visuals really help.
They do. There's this UI mockup included showing a sleek control deck and an inspection panel. It proves this project is moving past, thought experiments and into actual interface design.
Right.
But before we get into the buttons and the sliders of that interface, we need to establish how the system even understands what it is looking at, right? To build a mechanical filter, you first need a stable language to define what the system is judging.
Yeah, and the architecture approaches this by establishing a foundational vocabulary. We start at the very top of the funnel with what the paper calls feed ingress.
A feed ingress.
Which is really just the raw, unedited, totally chaotic stream of content coming from whatever platform you are connected to.
Just the fire hose.
Exactly, the fire hose. The filter cannot evaluate a raw, unformatted post. So the first operational step is normalizing that data into a content object.
Okay, a content object.
Right. This becomes the absolute minimum standardized entity that the filter acts on. It strips away all the platform-specific formatting and just standardizes the text, the timestamp, the reply position, and, any attached media.
But evaluating a bare content object still feels kind of inadequate, doesn't it? I mean, judging a single piece of normalized text is like judging a single sentence you overhear in a noisy, crowded room.
That's a really good way to put it.
Like, if I only hear the words "you are completely wrong," I have no idea if the person was joking or quoting a movie or escalating a bar fight.
Right. Context is everything.
Exactly.
Yeah.
And I see in the specs that the system wraps the content object in something called a context envelope.
Yes.
And if I'm reading the structural breakdown correctly, it is looking at the thread state, meaning it can mathematically assess whether a conversation is degrading into a brawl or elevating into a constructive debate, which completely changes how that single sentence should be judged.
The thread state is a perfect example of why the context envelope is so critical. Without it, automated systems tend to just flatten everything.
Right.
The envelope is a bundle of signals surrounding the object. So beyond thread state, it analyzes the author pattern, which assesses the historical behavior and the reliability of the person posting. Oh, interesting.
Yeah, and it maps the topic cluster to see how this fits into broader discourse. But crucially, it evaluates the event frame. Event frame. What does that mean in prep?
It basically asks the system, is this a normal Tuesday morning observation? Or is this a dispatch from a fast-moving, real-world emergency?
Oh, wow. So if you apply that to a highly toxic comment thread, the mechanics become incredibly powerful.
Absolutely.
A basic algorithmic moderation tool might flag an entire degraded thread as toxic and just hide the whole thing from your feed.
Which happens all the time.
Right. But because of the context envelope, this system can distinguish between a degraded conversation and a single, brilliantly argued counterpoint buried deep within that mess. It judges the post based on its specific context, not just by applying a blanket verdict to the vicinity.
Yeah, and the output of all that evaluation is what the architecture calls a placement vector.
Okay, placement vector.
The system takes the enveloped object and plots it onto an intelligence and morality space, the IQMQ grid, while attaching a strict confidence level.
So it's grading it.
Yes, and it also appends auxiliary modifiers like evidence density. It essentially generates a highly detailed, multidimensional nutritional label for the post before it ever reaches the user's screen.
A nutritional label for content. I like that.
Hmm.
But once the system has that label, the operational challenge kind of shifts to the human being looking at the screen, right?
It does.
How does the user actually govern this engine without needing a degree in machine learning? Because looking at the mock-up of the control deck, the design relies heavily on spatial controls.
Yeah, it's very visual.
You have this zone cursor
Right.
sitting on a quadrant map. You literally drag a target onto the grid to represent where you want your feed's baseline to be. And then there is a slider for the porosity radius.
Right, the porosity radius. It dictates how tightly the filter concentrates around your chosen target zone.
So it's like a focus ring.
Kind of. You can tighten the radius to enforce really strict boundaries, or you can expand it to allow content to bleed in from the edges of your preferred intellectual and moral coordinates.
I have to wonder about the psychological friction here, though.
How do you mean?
If I am the user, do I really want to feel like an air traffic controller just to read my morning news? Managing target zones and porosity radiuses sounds exhausting for someone who just wants to scroll while drinking their coffee.
Well, the design actually anticipates that exact user fatigue. What's fascinating here is, to prevent the interface from feeling like a chore, the architecture draws a strict, impermeable line between profile state and session state.
Profile versus session. Right?
Yeah. Your profile state is your durable identity, the long-term settings you've carefully calibrated over months. But the session state acknowledges your temporary moods.
Oh, that makes sense.
The interface provides these simple one-click toggles for session overrides. You have comfort mode, challenge mode, and survey mode.
Which means if I spend an evening going down an absolute rabbit hole of bizarre, low-evidence conspiracy theories just because I'm morbidly curious.
You simply toggle on survey mode. The system registers that this is a temporary expedition.
Oh, thank goodness.
Right. It suspends the normal feedback loop so it doesn't permanently warp your long-term filter. It basically protects your durable identity from your own late-night doom scrolling.
That is brilliant.
And additionally, the interface offers two distinct ways to consume the resulting feed. There's the timeline surface, which is the standard familiar vertical scrolling list, but it also introduces the space surface.
Space surface.
Yeah, it allows you to literally browse your feeds spatially, panning across the IQMQ map to see where different clusters of conversation are happening.
Wow. Treating the feed like an actual topography you navigate is a massive departure from treating it like a slot machine that just dispenses random dopamine hits.
It changes the entire paradigm.
But if I set up my space, we run into the classic algorithmic dilemma. How does the system learn and adapt to my changing tastes over time without aggressively trapping me in an echo chamber?
Ah, yes, the overfit trap.
Exactly. The document outlines a training life cycle to prevent what it calls the overfit trap.
Yeah, the overfit trap happens when a dumb algorithm learns what you click on and then so aggressively optimizes for that exact stimulus that it never shows you anything else.
The ultimate echo chamber.
Right. To avoid this, the architecture defines a four-phase life cycle. It begins with a cold start, where the system assumes absolutely nothing about you. Then it moves into calibration.
Calibration sounds like taking an eye exam.
It kind of is.
The system presents a bounded set of highly varied content across the spectrum to gauge your actual reactions and establish a baseline. From there, it moves to stabilization and finally into continuous live adaptation.
Precisely.
Let's use an analogy for this adaptation phase. If I walk into a haunted house out of sheer curiosity, the current attention economy algorithms think, he likes haunted houses, I will only show him haunted houses from now on.
Right, which is incredibly frustrating.
It is. So how does this specific system mechanistically separate my fleeting curiosity from my actual durable preferences?
It achieves that separation through a mechanism called the drift governor. And this operates based on a very rigid signal hierarchy.
Drift governor. I like the name.
Think of a mechanical governor on an old steam engine. If the load suddenly drops, the governor physically restricts the steam so the engine doesn't spin fast enough to just tear itself apart.
Okay, I can picture that.
The drift governor does the exact same thing for your profile. It limits how quickly your baseline can shift based on sudden spikes in weird activity.
See, most platforms today train their models on implicit weak signals. Like if you linger on a video for 4 seconds, the system treats that as a massive endorsement.
Yeah, it assumes intent where there is none.
This architecture seems to completely invert that logic.
It does. Explicit override actions carry the highest mathematical weight. So if you open the inspection panel and manually click less like this, the system treats that as an undeniable directive.
It actually listens to you.
Exactly. Strong behaviors like actively saving a post to a notebook or sharing it, those carry a medium weight. But weak signals, like dwell time, just staring at that haunted house video because you spaced out, those carry the absolute least amount of weight.
And the system compiles all these weighted inputs into a correction ledger.
Right. Yes, the ledger.
Over time, the ledger ensures the system learns deliberately and cautiously. It treats your explicitly stated intentions as vastly more important than your impulsive reflexes.
Which is how it should be.
For anyone listening, think about the last time you rage-clicked a terrible political take at 2 in the morning. On current platforms, you just ruined your algorithm for a week.
Oh, easily a week.
Here, the drift governor absorbs that anomaly, checks the ledger, and realizes it doesn't match your durable pattern.
And that cautious learning protects your adaptive profile. But, understanding how the filter learns is only half the equation.
Right, what does it actually do?
Exactly. The other half is what the filter actually does to the incoming feed in real time. This occurs in the mediation pipeline. And it's vital to recognize that this is not a binary spam filter that simply passes or blocks content.
So it's not just a bouncer at the door.
No. The pipeline assigns one of 5 specific surface actions to every single item.
And the 5 actions are elevate, pass, attenuate, cluster, or defer.
Right.
Pass obviously lets the post through natively. Elevate boosts its prominence. But attenuate and cluster represent a completely different approach to moderation. Clustering, for example, is brilliant.
It really solves the repetition problem.
If 50 people are making the exact same low-effort argument, the system doesn't need to show you 50 individual posts. It clusters them into a single, expandable card. You see the volume of the sentiment without it devouring your screen real estate.
Yeah, and Attenuate operates on a similar principle of visual hierarchy. Rather than deleting a post that falls outside your strict parameters but still holds some relevance, the system might fade the opacity, shrink the font size, or collapse the replies.
So it's still there, just quiet.
Exactly. And defer holds a post back entirely if the system needs more time to analyze a rapidly evolving thread.
That brings up a critical vulnerability regarding out-of-zone content, though.
Okay, let's hear it.
If I set my target zone very narrowly, does everything outside of it just vanish? Because if the system is doing its job perfectly, it seems like it would create the ultimate impenetrable echo chamber. I would never see anything that challenges me.
And in this design philosophy, that would be considered a catastrophic architectural failure.
Okay, so how do they fix it?
To counter the threat of an elegant cocoon, the paper introduces 2 structural bypass mechanisms. The first is challenge injection.
Challenge injection.
The system maintains a protected challenge budget. This mechanism deliberately seeks out content that falls completely outside your preferred zone, but which scores exceptionally high on intelligence, logic, and evidence density.
Oh, wow.
Yeah, it forces that content through the filter, ensuring you encounter well-argued opposition.
It mechanizes the act of breaking the echo chamber. It doesn't just hope you find opposing views. It budgets for them.
Exactly. The second bypass is reality passage, and this is tied back to the event frame we discussed earlier.
The emergency dispatch thing.
Right. If there is an urgent, highly corroborated breaking event, a natural disaster, a major geopolitical shift, the system overrides your strict filter rules.
So it forces reality through.
Yes. Even if the incoming posts are terse, panicked, and emotionally charged, which would normally score low on the MQIQ grid, the system recognizes that reality is knocking on the door. The reality passage ensures you are not insulated from the actual state of the world while sitting in your finely tuned intellectual bubble.
Okay, but if the pipeline is doing all of this, evaluating the author pattern, checking the thread state against the drift governor, clustering redundant arguments, and actively injecting a challenge budget, it requires massive computational power, which leads to a severe latency problem. Here's where it gets really interesting. If I open an app and have to wait 4 seconds for a single post to load because the system is deeply analyzing the author's historical morality, I am going to close the app.
Anyone would.
How does the architecture handle deep thread analysis without causing the feed to stutter and freeze?
The latency problem is solved by establishing a strict physical boundary between the live path and the background path.
Live path and background path.
Right. The live path is responsible for rendering the feed instantly. It handles only what is absolutely necessary. It looks up your profile, retrieves pre-computed data vectors, and puts the pixels on the screen. It is designed to be featherlight and lightning fast.
And the background path operates asynchronously, entirely out of the user's way.
Exactly.
That is where the heavy lifting happens. The background servers are continuously crunching author histories, running deep cluster analyses, and updating the correction ledger without ever interrupting your actual scrolling experience.
But inevitably, those two paths collide.
How?
The live path will encounter a brand new post that the background path hasn't had time to analyze yet. When that happens, the system applies what Nemotin calls confidence discipline.
I noticed that term in the specs. If the live path isn't confident about a post's placement vector, it doesn't stall the feed trying to compute a perfect answer on the fly.
No, it applies discipline.
Right, it might pass the post with caution, apply a mild attenuation, or if it looks highly volatile, defer it entirely until the background path can properly score it. The architecture prioritizes a seamless user experience over instantaneous perfection.
Yeah, that asynchronous division of labor is elegant, but it creates a massive vulnerability regarding user data.
Exactly. Think about it. If the background path is constantly crunching my exact tolerance for challenge, tracking my intellectual habits, and recording the specific boundaries of my morality.
It's an unprecedented level of surveillance, potentially.
That is the most intimate psychological data imaginable. If that data is sitting on a centralized corporate server, it is a goldmine for advertisers or bad actors. How does the architecture protect the user from the system itself?
The document specifies a profile vault, which operates on a local-first storage paradigm.
Local first, so it stays on my phone.
Yes, your adaptive profile, your ledger, your specific sensitivities, those live on your device, not in a corporate cloud database waiting to be monetized. Furthermore, the system is governed by an explainability architecture.
The explainability architecture. This means the user is never left guessing why the algorithm made a decision right.
Exactly.
Every item in the feed carries surface signals or route tags. You can click on any post and see the exact mechanical route it took to reach you.
It's total transparency.
Was it a strong match for your target zone? Was it forced through via your challenge budget? Was it a reality pass? The transparency is just built into the UI.
But, despite all these safeguards, a serious system design must anticipate how it might break or be exploited. The paper is remarkably candid about potential failure modes.
One of the failure modes that stood out to me was cosmetic gaming. This is just the reality of the internet. The moment you build a filter, people try to hack it.
Always.
Cosmetic gaming is when bad actors, or even localized LLMs, learn to mimic the tone and vocabulary of high IQ content without actually providing any substantive argument.
Right, the illusion of intelligence.
They use polite, elevated language to mask vacuous or malicious ideas, trying to trick the parser into giving them a high placement vector.
And the system counters cosmetic gaming by relying heavily on the evidence density checks within the background path.
So it checks the receipts.
Verifying the actual structural logic, rather than just scanning for sophisticated adjectives. The architecture also anticipates overfit calm, where the system accidentally aligns too perfectly with your comfort zone and your intellectual growth stagnates.
Oh, that makes sense.
And it flags explanation overload, where providing too many root tags and surface signals just clutters the interface and overwhelms the user.
The failure mode that requires the most scrutiny, though, is moral overreach. If this system is actively judging the morality and intelligence of human communication, the danger of it acting like a paternalistic, omniscient judge is immense.
It's a very real concern.
How does the system stay humble? Because if the interface starts telling the user, "I've decreed this to be the absolute truth," we are right back to the centralized platform dictatorships this entire project is trying to escape.
The safeguard against moral overreach is explicit modesty in the interface design. The system is mechanically forbidden from presenting its findings as metaphysical certainties.
So it's never 100% sure.
Exactly. Everything is presented as a provisional confidence level. But more importantly, correction pathways are placed directly in the user's hands. If the system incorrectly categorizes a nuanced argument as toxic, you tell it, and the drift governor adjusts the ledger.
So the success of this system isn't measured by traditional Silicon Valley metrics. It doesn't care about time on platform or daily active users.
Not at all.
Success is measured by the user's perceived signal quality and whether they retain exposure to meaningful differences of opinion without feeling overwhelmed.
Moving forward, the document outlines the deployment paths for how this architecture actually reaches the public.
Oh, how we actually get to use it.
Right. It could manifest as a standalone client or a browser extension that overlays existing platforms, or a hybrid architecture where you keep your profile completely local but leverage decentralized cloud processing for the heavy background path computation.
Which is a huge structural shift.
Yeah, the next step on the roadmap is the actual build specification, moving from this architectural blueprint to actually writing the code.
We have literally watched a philosophical ideal, the right to govern your own digital attention, crystallize into modules, pipelines, and a user-owned control deck.
It's pretty amazing.
It is. For everyone listening, think about the profound shift in power this architecture represents. We are talking about moving from being a passive resource that is farmed for engagement to becoming the active, protected architect of your own digital intake.
It's a fundamental shift from mindless consumption to intentional ownership.
Absolutely. And I want to leave you with a final lingering thought based on a concept buried deep in the privacy section of this technical document: the portability package.
Oh, yeah. That's a big one.
Think about the implications. If your trained profile, your exact tolerance for nuance, your specific intellectual metabolism, the thousands of micro lessons you've patiently taught your drift governor that is an exportable encrypted file that you truly own.
Right.
What happens when you plug that identity into entirely different digital realities? Imagine carrying your cognitive immune system with you, whole and intact across the entire internet.
It changes everything.
You plug it into a new social network, a research database, or a spatial computing environment, and the world instantly reshapes itself to match your capacity for signal. What does the web look like when the user finally holds the keys to the filter? We started this journey looking at abstract blueprints, but we are actually designing a cognitive home that we can take anywhere. Thanks for joining us on this deep dive. We'll see you next time.